Hello students, in previous lecture we have solved the examples which is based on factor theorem and remainder theorem. Today we are going to solve few examples from practice set 3.5 and which is related with the factor theorem and remainder theorem as well as the finding out the value of polynomials. Then first example from question number 1. Question number 1 here given, that is find the value of given polynomial, that is px, here polynomial which is given, that is 2x minus 2x cube plus 7, and here for the value of x is equals to 3 we have to find the value of this polynomial. Therefore here first of all focus here that x, the value of x is 3. For this value of x is equals to 3 we have to find out the value of this polynomial. Therefore px is equals to 2x minus 2x cube plus 7. Then we have to put the value of that x into this polynomial. Therefore here p3, that is the value of polynomial, this polynomial for x is equals to 3. Therefore 2 into 3 minus 2 into 3 cube plus 7. Then see here p3 is the value of polynomial, that is 3 into 2 6 minus 2 into 3 cube, that means here 27 plus 7. Therefore here we get p3 is equals to 6 minus here 2 into 27, that is 54 plus 7. Then p3 is the value of polynomial, that is 6 minus 54. Then here minus 48 plus 7. Therefore p3 is equals to minus 48 plus 7, that is minus 41. That is the minus 41 is the value of this polynomial for x is equals to 3. Then in question number 2, the example which is given here, see here, for following polynomials, find the value of here p1, p0 and p minus 2, and here few polynomials are given. Out of that, one of the polynomial, that is px, is equals to here x cube, and we have to find out the value of polynomial for this polynomial, that is here p1, for here x is equals to 1, therefore p1 is equals to here 1 cube. Therefore p1 is equals to 1 cube, that is 1. That is the value of this polynomial is 1 for x is equals to 1. That means the value of p1 is 1 for this polynomial. Similarly here for p0, see here px is equals to x cube for this polynomial. Therefore here p0 is equals to, putting the value of x, that is 0 cube, that is p0 is the 0, that is the value of this polynomial for x is equals to 0. As well as we have to find out the value of p minus 2 for the same, that is polynomial. Therefore here p minus 2 is equals to c minus 2 cube, and therefore p minus 2, that is the value of this polynomial for x is equals to minus 2, that is here minus 2 into minus 2 into minus 2, that is minus 8. Then that is the value of polynomial for x cube for x is equals to minus 2. That is about the examples which is given in the question number 1 as well as question number 2 from practice set 3.5, as well as we will solve the few examples from practice set 3.5 which is based on that remainder theorem as well as factor theorem. Then we will solve the question number 4. Then see here in question number 4 the example which is given here for the given polynomial, and here polynomial which is given here, that is px is equals to here mx square minus 2x plus 3, and here we have to find out the value of m. Then find the value of m if the value of polynomial for x is equals to minus 1, that is p minus 1 is equals to 7. Then see here using remainder theorem we have to find out the value of m. Then see here the polynomial which is given here px is equals to mx square minus 2x plus 3. Then here p minus 1 is equals to 7. That means here x is equals to minus 1. Therefore p minus 1 is the value of polynomial. Value of polynomial for x is equals to minus 1, as well as p minus 1 is also the remainder, that is p minus 1 is equals to 7, and therefore p minus 1 is equals to here m. Here we have to put down the value of minus 1 for x is equals to minus 1 square minus 2 into minus 1 plus 3. Then see here, but here p minus 1, that is value of that polynomial for x is equals to minus 1 is 7. Therefore here 7 is equals to m into minus 1 square. Therefore m into minus 1 square, that is 1, minus in bracket 2 into minus 1, therefore minus 2 is there, plus 3, and therefore 7 is equals to m into 1 m minus minus plus 2 plus 3. Therefore here m plus 5 is equals to 7. Therefore m is equals to 7 minus 5. Therefore here m is equals to 2. Then here the value of m for p minus 1 is equals to 7 for this value of polynomial is 2. Therefore here polynomial becomes, that is 2x square. Px is the polynomial here 2x square minus 2x plus 3. Then see here we can tally the example whether our answer is correct, that is by putting the value of x is equals to minus 1. Then see here, p minus 1. Then 2 into minus 1 square minus 2 into minus 1 plus 3. Then, but here p minus 7 minus 1, the value is 7. Therefore, 2 into minus 1 square 1 minus 2 into minus 1 plus 2 plus 3. Therefore, here 2 into 1 2 plus 2 plus 3, that is here 7. Therefore, here 7 is equals to 7. That means here LHS is equals to RHS. Therefore, here the value of m in this polynomial is equals to 2. And that is our correct answer. Then we will solve few more examples from practice set 3.5. Then all of you studied the remainder theorem as well as factor theorem. And when the remainder of division of polynomials is 0, then that divisor is the factor of that given dividend. We have to solve that question number 6. That is here one of the polynomial which is given here, that is py is equals to y cube minus 5y square plus 7y plus m. Then that polynomial which is divided by that polynomial, second polynomial, that is y plus 2, that is binomial. And if remainder is 50, then find the value of m. Find value of m. Then see here the example which is given, we have to read once again, that is to find out the given values. Then see here py, that is y cube minus 5y square plus 7y plus m, which is divided by y plus 2. Therefore here py is that is y cube minus 5y square plus 7y plus m is a dividend. It is a dividend. And here another qy, that is second polynomial in y variable, that is y plus 2 is a divisor. Then if we divide this py by the polynomial qy, then the remainder is 50. Remainder is 50. Then we have to find out the value of m. Therefore, see here, using remainder theorem, all of you have aware of that, the remainder theorem. See here, the divisor is y plus 2. Therefore, here a is equals to minus 2. Then here the value of this polynomial for y is equals to minus 2, that is p minus 2 is the value of polynomial, as well as p minus 2 is the remainder of this example. Therefore, here the value of that polynomial p minus 2, we don't know value of that, but here remainder is given, and therefore p minus 2 is the remainder. Therefore, here p minus 2 is equals to 50, and therefore we have to find the value of this polynomial for y is equals to minus 2. Therefore, we have to write p minus 2 is equals to, then have to write y cube. Then first of all we have to write the polynomial in y variable which is given, that is dividend. py is equals to y cube minus 5y square plus 7y plus m. And here y is equals to, or a is equals to minus 2. Therefore, y is equals to minus 2. Therefore, here p minus 2 is equals to, then putting the value of y, minus 2 here, minus 2 cube minus 5 into minus 2 square plus 7 into minus 2 plus m. Therefore, here p minus 2 is equals to, see here, minus 2 cube, that is minus 8, minus 5 into minus 2 square, 4, plus 7 into minus 2, that is minus 14 plus m. Then simplifying this, here we get, and putting the value of p minus 2, see here, the value of that polynomial is 50 for y is equals to minus 2 because it is a remainder. Therefore, p minus 2 is a remainder. Therefore, putting the value of that value of polynomial for y is equals to minus 2, that is 50. Therefore, simplifying this all, minus 8 minus 5 into 4, that is minus 20 plus minus 14, minus 14 plus n. And therefore, simplifying this, here we get 50 is equals to minus 8 minus 20, that is minus 28, minus 28 plus 14, that is, see here, minus 28 minus 14. Therefore, here we get, that is minus 42. Therefore, minus 42 plus m. And therefore, here m is equals to 50 plus 42. Therefore, here m is equals to, that is here 50 plus 42, that is 92. Therefore, here in the polynomial, the value of that m is 92. Therefore, we get that polynomial, that is polynomial in y variable, that is y cube minus 5y square plus 7y plus m. Then we can tally that the value of that polynomial, that is p minus 2 is 50 by putting the value of y is equals to minus 2. Then see here, minus 2 cube plus 5 into minus 2 square plus 7 into minus 2 plus the value of m, we got here 92. Then see here, value of that p minus 2, that is 50. Then minus 2 cube, that is minus 8. Then here minus 5 is there, minus 5 into minus 2 square, that is minus 5 into minus 2 square, that is 4 into minus 5, minus 20, plus, that is, see here, plus 7 into minus 2, that is minus 14 plus 92. Then see here, minus 8 minus 20, minus 28 minus 14 plus 92, minus 28 minus 14, that is minus 42 plus 92. Then minus 42 plus 92, that is 50. Therefore, here we get LHS is equals to RHS. Therefore, our answer, that is m is equals to 92 is correct. Then we will solve the last example from practice set 3.5, that is based on factor theorem. Then the example which is given in question number 9, that is here, using factor theorem. Then determine whether the polynomial, that is qx, is a polynomial which is a factor of the polynomial px given in the examples, that is given below. Then here there are two different polynomials which is given here. That is one of the example we will solve. That is px is equals to 2x cube minus x square minus 45. And here the second polynomial which is given, that is polynomial qx is equals to x minus 3. Then again read that example carefully. We have to determine whether the qx is a factor of that px polynomial which is given in this example. That means we have to find out that x minus 3, which is a divisor, is a factor of that given polynomial, that is dividend. Therefore, first using remainder theorem, then here we have to find out the value of polynomial, that is px is equals to 2x cube minus x square minus 45. For here x is equals to, or a is equals to plus 3. Then putting the value of, therefore here as the value of a, that is pa is equals to p3, that is the remainder, by using remainder theorem. Then we have to find out the value of polynomial for x is equals to 3. Therefore here p3 is the value of polynomial px for x is equals to 3. Then we have to find out the value of polynomial of px for x is equals to 3 is the remainder of that example. Therefore we have to find out p3 is equals to, then see here the example which is given here, that is px is equals to 2x cube minus x square minus 45. Therefore we have to find out the value of that polynomial for x is equals to 3, that is p3 is equals to 2 into 3 cube minus 3 square minus 45. Therefore here p3 is the remainder is equals to 2 into 3 cube, that is 27 minus 3 square 9 minus 45. And therefore p3 is equals to 2 into 27, that is 54 minus 9 minus 45. Therefore 54 minus 9, that is 45 minus 45. Therefore here we get the value for polynomially for x is equals to 3, that is 0. That means here 3 is the remainder. Therefore the remainder of this example is 0. And according to factor theorem, if remainder is here, remainder is 0, therefore here the dividend, that is qx, x minus 3 is a factor of that polynomial, that is 2x cube minus x square minus 45. That means here qx, therefore qx polynomial is a factor of px polynomial. That is all about the examples which is given in the practice set 3.5. Then you should solve the remaining examples from practice set 3.5, which is based on factor theorem, remainder theorem, as well as the finding out the value of given polynomial for the given value of variable. Thank you.